doing the last section, the last note for Unit 4. We still have 2 more days left, the 14th and the 16th, and then the 20th is when we take the actual test. So I'm going to quickly go through Unit 4, Day 6, which is isosceles and equilateral triangle. So this is basically trying to reinforce some of the content we talked about, nothing new. We defined what is an isosceles triangle at the beginning of the Unit 4, so you should be able to recognize it, but one thing we need to make sure is you guys understand the vocabulary that goes with it. So the base angle theorem states that if two sides of a triangle are congruent, then the base angles are congruent. So what it means is if the only information you have is that AB is congruent to AC, then you can conclude that angle B is going to be congruent to angle C. So that's what we're doing. Angle B is going to be congruent to angle C, right? And the same way applies the converse theorem. If angle, or let's write it as if two of the base angles are congruent, then the two sides are going to be congruent, right? So in this case, they gave us if D is congruent to F, as you guys can see it here, then I can say that the side opposite to it will be congruent. That makes DE congruent to EF. Sorry about my writing. I don't know why, but it is not EF. That's why it's important that you listen to me. So DE, that makes this the vertex angle. So every time you have a triangle, an isosceles triangle, the two sides that are congruent to each other are called the lakes. So this will be called the lake of the triangle. So this is the lake. This is the lake. And the side that is not congruent is called the base. Okay. And then the angle that is created by the two lakes is called the vertex. And the two angles that are equal to each other, B and C in this case, are called the base angles. Okay, this is important when they give you a word problem. So if they say if the base angle of a triangle, an isosceles triangle is this, then you should be able to put where it needs to go. And you guys will be able to see it when we go through the problem. So try this problem and solve each angle. So when I see this, I know it's an isosceles triangle because the two sides are given to be congruent. This is given to be the vertex angle. This is x and x. I don't know if this is 6. Okay, if that is 6 degrees, it doesn't look like it, but I bet it was a different number, but it is 6. So let me check my, all right, it was supposed to be 6x. I just checked into the original file. This was hidden. I know you guys don't have it, but this was supposed to be 6x, okay? And then this is x and x. So I know the D and F are going to be the same, so I just put the x's right here, and 6x was for E, so all I need to do is add it up to make it equal to 180, right? So when I take 6x plus 2x's, I'm going to add up to 180. So 6 plus 2 gives you 8x equals to 180. So you divide both sides by 8. And x would be 18 divided by 180 divided by 8, which should be 20, I believe. No, not 20. Let me get my calculator out so that I know. All right, it's 22.5. So x is 22.5. And the question is for each angle. It doesn't say for each variable. So I have to say, okay, this is 22.5. This is 22.5. And then 6 times 22.5, angle E would be 135. Okay, So that's what you guys have to do to find it. All right, the same thing applies for number 2. And I will let you maybe solve that part. But remember, this is an isosceles triangle, right? And this is x and 26. So I knew this is 26. That makes the base angle the same. So x would be 26. Now I need to solve for y. So I can just apply my isosceles triangle theorem, which is the two base angles are the same. So 26 plus 26 plus angle y equals to 180. So now your job is to solve for what is y. Okay. All right, for number 3, this is also an isosceles triangle. The two legs are going to be the same. So they gave you 17 as a distractor. So you guys have to make sure you pay attention to that one. So they gave you 2x plus 1, 15, and 17. So since I know this is my two base angles, then I know the two sides are going to be congruent. So I can easily say, okay, 2x plus 1 is equal to 15. Then I need you guys to solve for x and tell me what that is. So just to recap what we learned about an isosceles triangle, if this is the two sides, they're called the leg of the isosceles triangle. This is called the base. This is the vertex. X, sorry. And then these are your base angles. Okay, make sure you remember that. All right, next page is equilateral triangle. A triangle is equilateral if it has 3 congruent sides. 3 congruent sides. Okay, if a triangle is equilateral, then it is also equiangular. Angular. Both ways. If a triangle is equiangular, then it is also equilateral, right? Okay. All right. So they want you to rewrite the statement 7 and 8 as a biconditional. So you can say a triangle is equilateral if and only if it's equiangular. Okay. Or you can say a triangle is equiangular if and only if it is equilateral. All right, so more examples on the x. So remember, see how you see this is the same as this one? That makes this the vertex angle, and these two are going to be your base angle. So this is going to end up being 54. Okay, and then you can solve 54 plus x equals to 180. So what would be x? Okay. All right, another one. So you gotta have to pay attention to where the vertex angles are. Here, x is the vertex angle. Here, this angle is gonna be the vertex angle, right? Right here. But so I have to kind of, okay, in order to solve for this, I need to know what these two angles are, which I don't know, right? So I'm gonna go to this side of the triangle, see, this is gonna be 65, right? Because these two sides are equal, that makes the base angles the same. So I can say 65 plus 65 plus, I'm going to label this as y so that you're not confusing with the other, has to add up to 180. Okay, so then once I know what this angle is, which makes it the same as this one. Okay, so let's work it out so that you guys can get the answer. All right, so 65 plus 65 gives you 130, right? So this is 130 plus y equals 180. Y would be 50. Okay, so this would be 50. This would also be 50, which makes this angle 50. Now I can say x plus 50 plus 50 equals 180. And then x would be what? You should be able to get it, right? Subtract it from 180. Good job. All right, the next problem is kind of the same, but you guys have to read. Solve for x and y given triangle XYZ is isosceles with XY. So you can see that XY, this is the key. Always have to read the instruction. XY, which is this side, is congruent to YZ, which is this side, right? x, y, y, z. So all you have to do is to solve for x first, make it equal to 5x minus 3 is going to equal to 3x plus 5. Okay, so I'll do minus 3x from both sides. So 2x minus 3 equals to 5. Then I'll do plus 3 plus 3. 2x equals to 8. X is going to equal to 4. So that's what I got for this number 11. Okay, then for 12, the same thing apply. XY, which is this side, is congruent to YZ, which is this side. So I need you to set this equation up and solve for x for number 12. All right, 13. They ask you to solve for x and y. So, and it's kind of, so I guess we can do this in class, or I can just do it because we have time. So x is 30. This has to be 30, right? Because that's the base angle. So I can say x plus 60, 30 plus 30 equals to 180, right? Just to save one step. Minus 60, x would be 120, right? And then I know for y, let me use a different color. This is 30 degree because they are vertical angles. So this is 30. This is y. So I can do 2y, well, y plus 30 equals to 180. Then you can solve 2y equals 2 plus 30 equals to 180 minus 30, and then you guys can solve it. So this one is a little bit, not challenging, so I'll just do this. So this is 50 and 50, which gives you 100. That makes this triangle 80, right? That's what I have, right? So then I know this angle here and this angle here are going to be equal, right? And all right, this triangle is missing information. So this was technically supposed to be an equilateral triangle. So this was supposed to be equal to this, equal to this. So I think I'm missing that piece. So that makes this equal to 60 degree. This is 60 degree and this is 60 degree. So now you need to find what is this angle here. 50 plus 60 gives you 110. 180 minus 110 gives you 70. That makes this 70. Then you have to solve for x, which becomes, so y is 80, right? And for the x, I have to do x plus 70 equals to 180. So that add up to 140. So when you do 180 minus 140, you get 40 degree. Okay. Alrighty, let's go to number 10. So this is where the vocabulary becomes very important. Finding the measure of each side of the equilateral triangle with RS, ST, and TR. So if I draw a triangle, okay, and I can name it RST, doesn't matter where you put R and S. Because the word is equilateral, that means each of the sides are equal. So you can take any of the two sides and make it equal to each other. And I can say this is going to equal to 3x and just solve it. Okay, minus x, x would be 1. Or I can take 2x plus 2, make it equal to 5x minus 4. So this would give me plus 4, 6. This would give me x is 3x, so 6 divided by 3 gives you 2 again, right? So that doesn't matter. But it's really important for number 11 because this is an isosceles triangle. So it says a triangle ABC with AB and BC congruent, right? So they both have B. That makes B the vertex angle, so I'll just put it here. and I'll put A here and C here, just to, for, you know, for drawing purposes. So I know this side here, AB is equal to BC because it's stated here. So AB is given to be 4y. BC is given to be 3y plus 2. AC is given to be 3y. So the only two sides that I know are going to be congruent is this 2. So to solve for y, I have to say what 4y equals to 3y plus 2. So we'll do minus 3y from both sides, right? Y is 2. And that would be the answer. Okay. All right, the next one is our overlapping triangles. So there's not a lot on overlapping triangles. I think this is just more of the proof part. I think let me stop here and then I'll do another video for overlapping triangles. I think that would be better, so that you guys don't have to sit and listen for more than 20 minutes.